Hi everyone, so this is the video for the lesson 4.1 notes. So before we begin, I wanted to give you some tips to help you take notes from our video. So remember that you can pause or rewind whenever you need to. So if you didn't understand something, just rewind and go back. Or if you're working out a problem, pause it so you don't get lost. Another helpful hint is to write down anything you have questions on. So keep a running list so that way when you come back to class, you can ask me and make sure you understand everything. And then the last is to make sure you watch your videos prior to coming to class because we're going to discuss everything that's in the video in the following class. So for 4.1, we're learning about similar figures. And this is kind of an extension of what we learned last chapter for congruent figures. When we learned about congruent figures is that they have congruent angles and congruent sides, that they have the same shape and the same size, whereas our similar figures have the same shape but different sizes. So with similar figures, we have two main characteristics that we're going to talk about. And the first is that their corresponding sides grow or shrink by the same multiplier, and we call that the scale factor. Another way to describe the relationship between the corresponding sides is that they're proportional. And that's a big idea because we'll be using proportions to help solve and find missing side lengths. So if we take a look at our example picture, we have the smaller triangle on the left side that has sides of 3, 4, and 5. So if I pick a number to be our scale factor, so I'm just picking a random number, so I'm going to say that our scale factor is 2. So that means to get to our bigger triangle, we would multiply all of our sides by 2. So this triangle grew by a factor of 2. If we look at it backwards and we look at our big one first and then go to our small one, then that means that the scale factor to get to the small triangle from the big one would be to multiply by a half, which is the same idea as dividing by 2, but we usually think of it as multiplying instead of dividing. So the corresponding sides in similar figures are proportional. The other main characteristics of similar figures is that their corresponding angles are congruent. So this is how it's alike to congruent figures from last chapter. They had to have congruent angles as well. Remember we talked about the angle idea and that they didn't make congruent triangles? We'll learn next class more about that. So for similar figures, their corresponding angles are congruent. So if we take a look at our picture, we can see that angle A corresponds to angle D. So since angle D is 82, that means that angle A would also be 82 degrees. Angle B and angle E are corresponding. So that means that angle E would be 43 degrees. And our last angle, angle C, corresponds to angle F. So angle F would be 55 degrees. So to write our similarity statement, we could write that triangle ABC is similar to triangle DEF. Similarity statement. So a similarity statement is just a way to name the figures that are similar and tell that they are similar. So looking at our first example, it tells us that the two four-sided figures are similar, and they want us to complete each statement. So when we're asked about angles, we know that the corresponding angles are congruent. So if we look at angle E, we need to figure out what the corresponding angle in the top picture is. So remember from congruent figures, one way to do that is to look at their names, to know what angles match together. So E is the first one when the second figure is named. So that would correspond to the first vertice in the other triangle when it's named. So that means we have that angle A and angle E are corresponding. So angle A would be 53 degrees. So if we take a look at our next picture, it's the same idea. We're trying to figure out which pieces match, but for the sides, they always write them as a proportion, which is when we have two fractions that are equal to each other. So looking at the side that's given will help you figure out what the missing part is, because one triangle or one figure is going to go in the same spot. So for the first ratio, we have that AB is proportional to side EF. So those are the left sides of our figures, with the bigger side being on top, or the bigger figure on top. So it equals AD. So that would correspond to the bottom, or that goes with the bottom. So which side would correspond to that in the smaller figure? Very good, EH. So I would like you to pause your video and try examples 2 and 4. Okay, welcome back. So I hope that you found that angle B is 127 degrees because it corresponds to angle F. And that for number 4, the side missing was side BC. So let's take a look at our second example. So it asks us to determine whether the triangles are similar. So remember from the front, what we need to look for is that we have congruent angles and proportional sides. So let's check our angles first. So our first angle that has one congruency mark in the top triangle is angle A. So which angle corresponds to that in the bottom triangle? Angle F. Both of those have one congruency mark, and we can see that they're congruent. So angle A is congruent to angle F.
Is in the building. Please come to the front desk.
Angle B has two congruency marks, so those are corresponding. And angle C has 3 congruency marks, so those are corresponding to angle D. So once we look at that, we can see that we have 3 sets of congruent angles, which is what we need. So now it's time to check that the sides are proportional. So one way to do this is to write ratios and reduce them and see if their scale factors come out to be the same thing. So what I like to do is to pick the smallest side first. So the smallest side in our small triangle would be side 12. So I'm going to write a ratio and compare that to the other triangle's smallest side, which would be side 16. Once we look at those, we can see that our triangles are not turned the same way because 12 was on the right for the small triangle and 16 is on the left for the big triangle. So this one's actually reflected, it's flipped over. So if we reduce that by a factor of 4, we get that the scale factor for those sides is 3/4. So what I look for next is the biggest side. So the biggest side in the small triangle is 18, and the biggest side in the big triangle is 24. So if we reduce those by 6, we again get 3/4. So this is a good sign that these triangles are actually similar. We just have to check our last set of sides. So first we look for the small set, then we look for the big set. So now we're just looking for whatever numbers we haven't used yet, which in the small triangle that would be 15, and the big triangle that would be 20. Remember that those triangles are reflected. So we can reduce those by 5 and we get 3/4. So now we can see that all 3 sides have the same scale factor, so that means that they're proportional. So we can write a similarity statement and name our triangles. So going in color order, I'm going to go green, yellow, blue. So that would be angle ABC, or triangle ABC would be similar to triangle green, yellow, blue would be FED. So go ahead and pause your video and try our next example and to check to see if those rectangles are similar. Okay, so I hope you found that the rectangles were indeed not similar. We did have all congruent angles, they all equaled 90, but when we wrote our ratios to check to see if the sides were proportional, we came up with different numbers. So that would tell us that the rectangles or 4-sided figures are not similar. If you don't get the same ratio, we don't have similar figures. So let's take a look at our next examples. And these ones are using the idea of proportionality in similar figures to find missing sides. So we have 2 4-sided figures again. They told us that they were similar, and they wanted us to find the 2 missing sides, x and y. So we can compare the sides and write a proportion to find that missing variable. So I'm going to look for x first. Okay, so I'm going to put x on top. I don't have to. You can write the different proportions and get the same value, but I like to put the missing variable in the top. So in this quadrilateral, x was in the top side, so we would look for the value that's in the top. As long as our shapes are rotated or orientated the same way. So x would be proportional to 2. So the other side over here doesn't have a measurement. This one has a y, so that's not helpful. So look for another side that has a measurement. So if we look at its counterpart, corresponding side, they both have numbers. So we would put this one on the top, since I put x on top, and then it corresponds to 5. So now we have a proportion that's only missing one value, one side set number, so we can solve this for x. So remember from algebra, the way to solve a proportion is to cross multiply. So x times 5 equals 5x, and then 6 times 2 is equal to 12. So now that we have a one-step equation, we just divide by 5 to solve for x. Don't get too mad that it's a fraction. It's okay. Just don't divide it out. Leave it as a fraction. Make sure you check to see if you can simplify, which we can't. So our answer for x is 12 over 5. So I'd like you to pause your video and solve and find y, please. Okay, so we should have got that y is equal to 3.84. So I know you're saying, well, why did you make that one a decimal when you made us leave the other one as a fraction? And there's a good answer for that, because in our original problem, we started with a decimal in our fraction. So if you start with a decimal, it's okay to leave your answer as a decimal, but in this one, we didn't have any decimals, so we had to leave our answer as a fraction. Okay, so I would like you to pause your video again and try the next two examples in that same row. Okay, so for the middle example, we got 9. And for the last example, you had to be careful because those two pentagons were not turned the same way. So what I did was I rotated this left one, or the right one, turned it around to make it orientated the same way so I can see my corresponding sides. After that, I wrote my proportion and got that x was 16 over 5, leaving it as a fraction since we started with no decimals. So let's take a look at our word problems, our last set of examples. So for this bottom one, it gives you a lot of information, and the most helpful thing to do for these is to draw a picture. So they told us that a utility worker is 5.5 feet tall. Here's my happy utility worker, 5.5 feet tall. And then they told us that he has a shadow that's 4 feet long. So here's my shadow. And then it says, at the same time, a nearby utility pole casts a shadow that's 20 feet long. Find the height of the pole. So I ran out of space, but here's my pole. Here's the shadow of the pole at 20 feet. So it says to find the height of the utility pole, and once we drew our picture, we can see that that's the value that we're missing. So you can pick whatever letter you want to represent that spot. I'm going to use X because that's the favorite letter of math teachers ever. So once we have that, we can see how we have similar figures. If we connected those, we'd have triangles, and it would be kind of like what we did up in the first beginning examples. So we can write a proportion comparing those two similar things. So if you want to do what we did up here and put X in the top spot, you can. You don't have to. There's a bunch of different ways to write this proportion and still have it all come out the same. I'm going to do it with X on the top just so we have some consistency. So X was the height of the pole. So I'm going to put it over the height of the person, which is 5.5. So now I go back to the picture with the pole, and we knew the shadow, and I'm going to put it over the corresponding part, the shadow of the person. So we would cross multiply, divide. We end up with that X is equal to 27.5 feet. There's two reasons why I left my answer as a decimal. One, our original problem had a decimal. 2, since this is a real world application, if we left it as the equivalent fraction, which was 55/2, that wouldn't help us figure out how tall the utility pole actually is. That's just some random arbitrary number where we can't visualize 55/2 feet. But 27.5 feet, we can kind of see that more clearly. So before we end the video, I'd like to point out that there are other ways to write this proportion. So we could have done 5.5/4 equals x/20. 5.5/x equals 4/20. And there's 1 or 2 other ways. So just remember that it doesn't necessarily matter if you do it exactly the way that I did it, as long as the corresponding parts are either across from each other or on top of each other. Okay, so go ahead and pause and do the last example. Okay, so when we set up our last example, this one's a little bit different and there's not really a picture that we can draw. So remember, whenever they tell you anything with a map, they're always going to give you the scale of the map, and that turns into half of your proportion. So I am sure to include the units on that when I write my proportion, so that way I can look at my other piece of information they give us and mash up the units and see where it goes. So I knew that the 54 kilometers went in the bottom because we had kilometers in the bottom over here. After that, you just cross multiply, and we get that our answer is 9 centimeters. Thank you for watching.